Today, we are going to master the very foundation of all software, sequential execution. This is the bedrock upon which all complex systems are built. Sequential execution is the default control flow of a program. It is quite intuitive. The computer processes your script just like you would read a book, moving from the top of the file down to the bottom line by line. This brings us to a vital concept, predictability. Because each line must be fully completed before the next one begins, we can always predict exactly what state the program will be in at any given step. There are no surprises in a purely sequential flow. To help us structure this flow, we follow the IPO pattern, which stands for input, process, and output. Let's look at how these three steps connect. First, we have input where the program receives data. Then notice how we move to the next stage, process, where the sequential logic actually happens, such as a mathematical calculation. And finally, output, where the result is displayed. This progression is what we will explore in detail today, starting with how to visualize this flow in our code. Building on the sequential execution we just covered, we need a reliable structure for our logic. This is where the IPO pattern comes in. It is the standard blueprint for almost every sequential program you will write. First, we have input. This is the stage where the program collects data, perhaps from a user typing at the keyboard or from variables we've defined like a price or a quantity. Without input, our program has nothing to work with. Next is processing. This is where we perform calculations or apply logic to the data we just collected. For instance, multiplying that price by the quantity to find a total. Finally, we reach output. This is the culmination of our sequence, where the process information is presented back to the user, such as printing a receipt or displaying a message on the screen. To make this even clearer, look at this table. It shows exactly how raw data transforms through a linear sequence into a finished result. Let's see how sequential execution dictates the success of mathematical calculations. In programming, the computer follows our instructions line by line, which means the order of our operations is critical. We have to consider calculation dependency. You cannot calculate a text amount if you don't know what the subtotal is yet. The program requires the output of one step to serve as the input for the next. Let's look at this invoice case study. First, we define our variables and calculate the subtotal. This value is stored in memory, making it available for future lines. Only after the subtotal is established can we calculate the text. If we attempted to move this line to the top of our script, the program wouldn't know what value to apply the text rate to. Finally, we add those two results together to reach the total. This step-by-step progression is how variables update as the program flow moves downward. A very common logic error for beginners is trying to output or print a result before the calculation has actually occurred. The computer doesn't know what you intend to calculate later. It only knows what has happened on the lines it has already executed. So let's see how sequential execution applies to text data, what we call strings. The logic remains the same. The order of operations determines the final result. In this example, our input consists of two raw strings, Python and programming, both in lowercase. Now look at the processing stage. We have two distinct steps. First, we must capitalize the first letter of each string. Second, we concatenate or join them together with a space in between. Notice that if we change the order and concatenate it first, we will have to manage the capitalization of a single longer string, which might require different logic. By following this sequence, our output is the perfectly formatted name, Python programming.